So today I want to talk a little bit more about a broader category of ciphers called substitution ciphers. We have already done the Caesar cipher, which is an example of a substitution cipher. And the great weakness, as we saw, of the Caesar cipher, the reason it was so easy to decode is because there's really only a few patterns that you can do. Specifically, there's 26 different configurations because all you need to know is how many you're shifting by. So if you could, for example, in this example, you're shifting by 2, A going to C, B going to D, that would be a shift of 2. And if you're only going to have 26 different possibilities, it's very easy, especially with a computer, to check all of those possibilities and then just figure out which one's correct. Um, But like I said, Caesar is a broader. It's an example of a broader category called substitution cipher. So you don't necessarily need to only change them with a very simple predefined pattern. There are other ways that you could potentially encode. So, for example, you could also do something in which you're doing some kind of swapping. So you could have potentially a cipher that went where A went to B and B went to A. Oops, I erased. That looks like an R. That's supposed to be a C. But you could have a case where C goes to D and D goes to C. But the possibilities don't end there. Of course, you could have E go to H, and then H is going to G, and G is going to K, and basically you have a very, very large number of possibilities. The trick is to get something which can be easily described in a rule, because of course anything you do, you need to undo as well, or you're not going to be able to decode it. The trick is to come up with something where you can really make it look complex, but be relatively easily apply a formula in order to be able to decode it. If you want to get more specific about how many substitution cipher possibilities there are, you think about it this way. You have a total of 26 characters, right? And your 26, let's say in that scenario, A can be mapped to a total of 25 different things. And then out of those possibilities, B can be mapped to a total of 24 things. And C can be mapped to a total of 23 things, which are now left, etc. So it has this factorial um, kind of possibilities. So you really are tons of different things. So in the Caesar cipher, you only really needed to check 26 different possibilities. But imagine if you had to check 25 times 24 times 23, or effectively 25 factorial possibilities. That would be a lot of checking, and you couldn't do that with such easy methods as we've shown. Okay, so on the practical side, let's look at some code, which I'm sharing with you today. And we're going to move over to here. And here we're going to do a multi-step substitution. And I'm going to combine for this. I'm going to combine two pretty simple steps just to start giving you an idea of what you might do in order. So all I'm going to do is I'm going to swap the O with the A. Okay, so swap an O with an A. Then after I do that, I'm going to perform a Caesar shift of 5. So that way everything's getting scrambled, but O and A are effectively getting double scrambled, or scrambled by 2 rules. But then, of course, everything I do, I need to undo in that reversed order. So let's just go ahead and take a look, and hopefully we'll get a better example. So I'm going to compile and run this guy, and we'll see. Okay, so here's my original phrase, the I love rock and roll. The first thing I do is simply switch the O, so it becomes I lave rack and rack und Raal. And then I put the Caeser on, the Caeser shift on. So now it really looks unrecognizable. To get it back, I undo my Caeser shift and I'm back to a lav rock und roll. And then to get all the way back, I need to also do the, this should say unswapped, but I should also undo the swap. Now, if we look down at our 26 possibilities, what this means is that none of them is going to be completely clear. Although we can see, because we know what the after the swap is going to be, it's pretty recognizable, right? Like you could, a lot of the words are intact. You could pretty easily figure out that this was the right word. But if you add one or two or three more swaps, all of a sudden it's going to be much more difficult, especially if it involves some of the letters which occur more frequently. It's going to be much more difficult to get a hold on that. So there's striking this balance between the simplicity of the rule for encoding and but if you make it too simple, it's going to be too easy to decode. If you make it too complicated, it's going to be too difficult to do efficiently. But that said, with a computer, you can do a lot of things pretty efficiently. So what I'm going to leave you to do is experiment with different ways that you could encode. So let's just say the simplest way I could extend this, and you guys can do this if you want. You can also get more creative if you want. Let's add a couple more swaps. I just had to clear up a couple things. So what I did here to increase the complexity is I did a couple of swaps. So I swapped O and A, then E and I, then T and S. So 3 swaps. So if I do 3 swaps at the top, I also need to do the same 3 swaps at the bottom to get back to where I started. And you can see that this is going to increase the complexity because now if I go back and look at the output, now even after the swaps, I'm getting something that's it's getting more difficult to see. Now I don't have a lot of full words left in there. If you know what you're looking for, yeah, I lavi rak und Raal, that's still somewhat comprehensible if you know what you're looking for. But you can see that by adding to the swaps, you get increasingly to something that's more complicated. And this is, of course, assuming you're still making the assumption that they're using a Caeser cipher. If you did something that was completely without a Caeser cipher to complete your encryption or your substitution cipher, you couldn't get it down to this many possibilities. So what am I asking you to do? So I'm giving you this to play with, and I want you to come up with a relatively strong encryption. So you're going to try to figure something out where you can mix things up so much using a substitution cipher. So every letter is always represented by the same different letter. Using that substitution cipher, you're going to mix things up and try to make something strong enough that you cannot decrypt it by simply looking at a set small number of decryptions to figure out which one it is. So basically, I'm asking you to experiment a little bit. I want you to come up with a method to have a more complicated encryption pattern. The requirement is that it's still a substitution cipher, so you're still replacing one letter with another, but in a more complicated way. And then all you need to do for today is let me know what that method is. And in the next class, we're going to talk about how we can attack and try to decrypt even more complicated encryptions like this. Hopefully that helps. I will talk to you later.